Hello my dear students, it's my pleasure to meet you today. Today inshallah we are going to study the lesson of vectors. We will continue vectors. We will study the operations on vectors and what is the norm of vectors. So follow me please. What is the norm of the vector? We have here norm of a vector. What is the norm of the vector? Look carefully at this symbol here. We have the symbol is different from this symbol. This symbol means the absolute value of a number may be -3 equals 3 or 3 equals 3 also. But this symbol is different because it's double dash here and double dash, vertical dash, and we call it the norm of the vector A. So if we have a vector A like that equals x and y, okay, so its norm is equal to square root x power 2 plus y power 2. So it gives a number. This number represents the magnitude. If we have here x-axis and y-axis, and we have this vector A, say this vector A equals 3 and 4. So to calculate its norm, which means that the length of the position vector OA here from this part to this point, from initial point to terminal point, we will find square root 3 power 2 plus 4 power 2 will give 5 length unit. 5 length unit means 5 centimeter, 5 meters, 5 kilometers, and so on. It's just 5, okay? So the norm of the vector gives the magnitude of this vector or the length unit of this vector. Okay, let's move to another definition. Yes, we have here some definitions. What is the zero vector? Zero vector, from its name, it's zero, but it's at the same time vector. So we call it zero vector. It's just zero and have a direction, and its expression like that, 0 and 0. If we have x-axis and y-axis here, its position here 0 and 0, which is the origin point, and we express the origin point when it's vector as 0 and 0. And 0 and 0 here belongs to R2. Which is R2? R2 is any point here in the xy coordinates. Okay, so 0 vector like that equals 0 and 0. Okay, let's move to a question here. An example: if A, the vector A, equals 6 and 1, and the vector B equals 1 and 2, find the norm. The norm of what? Of A minus 2B. This norm of this vector means we must first find out or calculate vector A minus 2B. Yes, we can put vector A here, 6 and 1, like that, minus 2 multiplied by the vector 1 and 2. 6 minus 2 times 1 equals 4. 1 minus 2 times 2 equals -3. So this vector equal 4 and -3. What is this vector? This vector is A minus 2b as a vector, but we would like to find its norm. The norm of a minus 2b here equals square root 4 power 2, which is this part, plus negative 3 power 2. It will be equal 5 length unit. So the norm of this vector equals 5 length unit. Okay. My dear students, it's very easy for you to find subtraction, multiplying, or dividing, or adding some vectors. So concentrate with me now to to solve a new question. We have here another question. If a, the vector a here, equals 2 and negative 3, the vector b equals 3 and 5, and the vector c equals 12 and 1, and we find you have to find c, the vector c, in terms of the vector a and the vector b. Solution: we would want to find the vector c in terms of a and b, so we put c, the vector c here, k multiply a plus l multiply the vector b. K and l is a constant or real numbers, belongs to R. So k multiplied by the vector a, which is 2 and negative 3, plus the vector l multiplied by b, which is 3 and 5. So c here equals k multiply 2 and multiply negative 3 will be 2k minus 3k here, plus l multiplied 3 and 5 equals 3l plus 5l. By adding, it will be 2k plus 3l it's just comma here, and negative 3k plus 5l. Okay, but we have c, the vector c, equals 12 and 1. So we can make two equations to find k and l. So 2k plus 3k okay is positive here. 2k plus 3k equals 12. From this part, 2k plus 3k equals 12. And we have another equation here, which is negative 3k plus 5l equals 1. And we can, by solving these two equations simultaneously, we will find that k equals 3 and l equals 2. And we can put c equals ka means 3a, a 2 and negative 3, plus and this part L plus L multiply B. L here equals 2 multiply B, which is 3 and 5. So the answer will be 3 multiply 2 equals 6. 3 multiply negative 3 equals negative 9, plus 2 multiplied 3 equals 6 also, plus 2 times 5 equals 10. So the answer will be 6 plus 6 equals 12, and negative 9 plus 10 equals 1. Okay, so we expresses C in terms of A and B. We can write that C equals KA from here. K equals 3A plus L equals 2B, and we can satisfied by this part because the request here write C, the vector C, in terms of A and B. So we have found that K equals 3 and L equals 2 from this part. So C equals 3A plus 2B. And now we have expressed the vector C in terms of the two vectors A and B. Let's move, my students, my dear friends, to another definition, which is position vector. What's the difference between vector and position vector? Look carefully at here. If we have x-axis and y-axis, any vector can be started from any point of starting, as this one, A, B, as example. But position vector must start from the origin point to this point, say it's equal M. So OM is the position vector. So the definition of position vector is a line segment or a directed line segment, directed line segment. Its starting point is what? Is the origin point. Okay? And its terminal point or end point here, it's any point belongs to R2. What is R2 again? R2, any point here in the XY coordinates. Okay? Let's move to another definition. The definition is, what is the equivalent vectors? If we have a vector here or a position vector, we can draw in the XY coordinates many vectors, an infinite number of vectors equivalent to it. What is the meaning of equivalent? Equivalent means that this vector equals this vector in magnitude or length unit and its direction also. So we can move to the definition by drawing here. Here we have XY coordinates. And we have a position vector here, say OA. And we can draw in this OX coordinates or this plane infinite number of vectors, are all of them equivalent to this vector OA because they are equal in magnitude or in length here and have the same directions. Many vectors can represent the vector OA. So we have infinite number of vectors can represent the position vector of OA. Okay. So we have the length unit here, OA, if A as a vector equal x1 and y1. We know, as we said before, that the norm of OA will be square root x1 power 2 plus y1 power 2. And what about fundamental unit vectors? What about unit vector as it is? If we have x-axis and y-axis here, and if we measure 1 unit here in direction of x-axis, 1 unit, just 1 centimeter, 1 millimeter, 1 meter, as it is. So it called unit vector. Unit vector here called I. So I, it's a unit vector in direction of x-axis. Okay, we can call it I. And we have also a unit vector here in y direction, and its magnitude equals 1, and we call it j. So I can be represented by this number or this coordinates 1 and 0. Why 1 and 0? Because it has in x-axis 1 unit, but it hasn't in y-axis. So it's 1 and 0. And if we would like to find its coordinate, its norm here, square root 1 power 2 plus 0 power 2, of course the answer will be 1. And the fundamental unit vector j, which is this vector here, and I is this vector in this direction, equals 0 and 1 in Cartesian form. And if we would like to find its magnitude or its norm, will be square root 0 power 2 plus 1 power 2. It's also equal 1 length unit. So unit vectors here are very important for our lessons, and we will go to write an example here to express these vectors. Okay, let's move to another example. If you have an example here, express about the vector A. Vector A equals 2 and 3 as example, and we would like to find it or write it as fundamental unit vector, or express it by using fundamental unit vectors. This A equal 2 and 3. This is the Cartesian form. We can write it as 2i plus 3j. Okay, 2i plus 3j. And if we have another vector b, 0 and 3 as example, then we can express it as this part or this form. I is 0 here, so it's just 3j. Why 3j? Because we have here 0i plus 3j. Okay, so b can be written as just 3j. And if we have another example as the vector c, and vector c equals 2 and 0, and we want to express it by fundamental unit vectors, we write c as 2i plus 0j, so it's equal 2i. Okay, and if we have another vector like d, the vector d, this vector equals 3 and 9, and we would like to express this vector in fundamental unit vector form, so d equals 3i plus 9j. It's very easy for you, my dear students. Okay, let's move to another example. Okay, we have another example here to express. We have polar form. What is a polar form, my dear students? Polar form. We have three forms of expressing the vectors. We have first Cartesian form like that, x and y. We have fundamental unit vectors form, x I plus y j, like this. And we have another form called polar form, related to scientific or scientist polar. Polar says that we can express any vector by this expression, a as example and theta as an angle. What this norm and theta? If we write x and y coordinates, and we have a here as a vector, we have here y, and this part equal x, and this is right angle triangle, and this vector is a. Say the point A here, x and y. Okay, and we have the direction of this vector, which is theta. Theta means the angle that the vector makes with the positive direction of x-axis. And we want to express the vector. The vector here equals this length, say as example 5, if it's 5 unit length, and theta says the angle equals 30 degrees. So we can express the vector A by 5 and 30 degrees. 5 and 30 degrees, 5 means the unit length or its length, but 30 means the angle that the vector makes with the opposite direction of x-axis, as we said. And if we would want to convert from polar form to Cartesian form, we put like this: 5 cosine 30 and 5 sine 30. So cosine 30, sine 30 equal half, so it's will be 5 over 2, and cosine 30 equal root 3 over 2, so 5 over 2 root 3. This is the Cartesian form, and we can put it in fundamental unit vectors form: 5 over 2 root 3 I plus 5 over 2 j. Please concentrate that if we want to express it in fundamental unit vectors, we put plus between them. Okay, and it is needn't to put brackets here, but if we express it as polar form or Cartesian form, we put it as these braces or that pair. Okay, where from comes 5 cosine 30? We know that here, that is x and y, any ordered pair here in coordinates x and y. So what is x? X here, if we have right angle triangle, x here means this part, which is a, the norm of a, cosine theta. And what is y? Y here is the same norm, sine theta. So y here is a cosine sine theta, and x equals the norm cosine theta. Okay, so it's x and y. So can express them as this part. Okay, let's move to another question. We have to know the convert from polar form to Cartesian form or fundamental form, or vice versa. So we will get some examples here to explain that and practice that. Okay, let's move to the example here. We have example. We have the vector A equals equals 10 root 3 and 60 degrees, and the request is convert this vector into Cartesian form. Okay, A here equals 10 root 3 cosine 60 and 10 root 3 sine 60. Okay, what is the answer here? If you use your calculator, you will find that x here equals 5 root 3 and y here will be 15. So it is the Cartesian form, and if you want to express it using fundamental unit vectors, will be 5 root 3 I plus 15 j. Okay, my dear students, let's take some break and we will return again. Be with us. My dear students, I am here with you again. Let's continue our discussion about polar form and Cartesian form. If we have a Cartesian form and we want to convert it to polar form, let's move to this example. If we have a vector A here equals 4 and 4 root 3, and you want to convert this vector to express it in polar form. First, we have to find the norm of A. What is the norm of A? Yes, we put 4 power 2, which means x power 2, and 4 root 3 all power 2. Don't forget to put brackets here if you use your calculator, because if you don't put 4 root 3 all power 2, the calculator will calculate root 3 power 2 only multiplied by 4. So concentrate to put the two braces here or brackets here around 4 root 3. Okay, we will use our calculator and the answer will be 8 length unit. And now we want to find or calculate the angle theta. We have here y and x, because this x-axis and this is y-axis here. Here theta, if we find tan theta, which is y over x, and we know that this is x and this is y, so tan theta, which is the angle that the vector makes with the opposite direction of x-axis, tan theta here equals y over x. What is y? Y here is 4 root 3 and x here is 4. So tan theta equals root 3. By using your calculator, or you know that shift tan theta or the inverse of tan minus 1 root 3, or you can press shift in your calculator shift tan and you press root 3, the angle here will be 60 degrees. Okay, but you concentrate about something. Here y is positive, x is positive, and we know that from the first term studying that we have here first quadrant, second quadrant, third quadrant, and fourth quadrant. If x here positive and y positive also, then the angle will lie in the first quadrant. But if x is negative and y is positive, then the angle will be in the second quadrant, and its magnitude equals 180 minus theta. 180 minus theta. But if x is negative and y is negative, it lies in the third quadrant, and its magnitude equals 180 plus theta. If x is positive and y is negative, then it will lie in the fourth quadrant, which is 360 minus theta. So we have here y is positive, here 4 root 3, y is positive, and also x is positive. So the vector completely lies in the first quadrant, and the angle theta lies in first quadrant here. So as it resulted from calculator, the angle theta here equals 60. So the vector A here, we can express it as the magnitude, which is 8, and the angle, which is 60. So we have here the vector form, the polar form, sorry. We have here the vector A equals 8 and 60 degrees. So this is the polar form. Let's discuss about another example to practice how to convert from Cartesian form to polar form. We have here, if another vector B equals 5 root 3 and negative 5, and pay attention to the sign. Here we have x and y. We know that x now is positive and y is negative. So the angle, of course, will be where x is positive, here like that. We can make something like that to move it, and y is negative, so y here is negative. So the angle will be in the fourth quadrant with x-axis, so will be theta. Okay, first we have to find the norm of B. As we said before, the norm of B equal 5 root 3 plus negative 5 power 2. And again, concentrate about putting brackets here, around 5 root 3, and put another bracket around negative 5, because if you don't put brackets here, the calculator will find 5 power 2 only, but multiply by negative. So don't forget to put these two brackets in calculator. So we have here B equals 10 length unit. So we have found this part, which is 10, and we wait for the angle here for this vector B in polar form. Okay, tan theta equals y over x. Y here is negative 5, and x is 4 root 3. Okay? And pay attention, you will not put negative in your calculator. You just try to put shift tan 5 or 5 over 5 root 3 or 1 over 3. Don't put negative. And this angle, maybe we call it alpha because it's a positive angle only. This angle will be 30 degrees. But we know that the angle here or the vector here lies in the fourth quadrant. Fourth quadrant means that we must calculate 360 minus 30, and the answer will be 330. So the angle will be 330 degrees. This part again, when you calculate, my dear students, when you calculate the angle theta, if we have negative, ignore negative for a part of time. When you calculate shift tan theta, shift tan 1 over root 3 equals 30. We can symbolize it by alpha, and we have x is positive and y is negative, so it lies in the fourth quadrant. And to calculate the angle in the fourth quadrant, it will be 360 minus 30. 360 minus 30 will be 330 degrees. Okay? My dear students, let's move to another important thing about vectors. If we have many vectors in the coordinates, so some vectors will be parallel like that, and some vectors will be perpendicular like that. So we will give an example to express that. If we have here x-axis and y-axis, here x-axis and here y-axis, and we have two parallel, this is the position vector of a vector as A or OA, and we have another vector parallel to it. So we know that it makes the same angle with the positive direction of x-axis. So tan this angle, of course, will be tan this angle. We know that tan this angle, which is theta, equals m. What is m? It's the slope of this straight line carries the vector. So if we have two vectors A and B, and these two vectors are parallel, of course m1 will be equal m2. What is m1? It's the slope of the first vector, which is y1 over x1. If we have A equals x1 and y1, and if we have the vector B will be x2 and y2, of course m2 will be equal y2 over x2, and they are equal. Why they are equal? Because, as we said, that the same angle, that they have the same angle of inclination on the positive direction of x-axis. And what about y1 over x1 and y2 over x2? We know from Pythagoras theorem here, if we complete the triangle, this part as x and this part is y, and tan theta equals y over x, which is opposite over adjacent. So we know that the slope which expresses the straight line carries the vector equals y over x. So the slope of vector A equal y1 over x1, and the slope of B equals y2 over x2, because they are parallel, and vice versa. If the slope of A equals the slope of B, then the two vectors are parallel. Okay, let's discuss about perpendicular of two vectors. If we have a vector here and another vector here perpendicular to it, so as we know before that m1 multiplied m2, which the slope of the straight line carries the first vector, and m2 is the slope of the straight line carries the second vector, their multiplication equals -1. That means that m1 equal -1 over m2. Okay, if m1 multiplied m2 equal -1, then the two vectors a and b here are perpendicular. Okay, and if they are perpendicular, then m1 multiplied m2 equal -1, or m1 equal -1 over m2. Okay, my dear students, let's discuss about the next example, and it will explain it to clear to you. If we have a vector a here, this vector equal -2 and 3, and another vector b equals -4 and m. Look carefully at this m. The question is to find m. Find m where, or in what condition? If a, the vector a parallel to the vector b, and second condition if a perpendicular to the vector b. As we said before, we can say m1. What is m1? It is the slope of the straight line carrying this vector, which is y over x, means 3 over -2. Can put negative here. And m2 here will be m over -4. And in the first case, a parallel to b, so m1 of course will be m2 equal m2, so we can put m over -4 here equals -3 over 2, so m equals -3 multiply -4 over 2, so the answer will be 6. But the second case, when the two vectors are perpendicular, m1 equal -1 over m2. That means we have here m2 here, we can put it as it is because of m, and this m, which is m1, we can find a reciprocal of it, and we can convert also its negative to be positive. So we can write as 2 over 3. So m here will be equal to times -4 over 3 by cross multiplication. To find m, just multiply 2 by -4 over 3, and the answer will be -8 over 3. Okay, look carefully at this. We have two parallel vectors, so m1, which is the slope of the first, equals the slope of the second as this part, and we have found m equal by using cross multiplication, -3 multiplied -4 divided 2 equals 6. And if we have a perpendicular to b, then this m, which is the first slope, equals this slope, but it's reciprocal with converse of the negative to be positive, or low, if it is positive, will be negative. So we put m over -4 equal reciprocal equal 2 over 3, and convert the negative to be positive to get -1 if we multiply them. Okay, and by using cross multiplication, we have found that m equals 2 multiply -4 over 3. Now, my dear students, we will start a different part, which is operations on vectors, or how to express some adding and subtracting vectors. So we'll study triangle vector. If we have a triangle here like that, triangle ABC, and we have a vector in this direction called M, and we can express also another vector in direction of BC, say N. So we can express the sum of the two vectors by the vector in the opposite direction of them. This vector starts from A to B, and second vector starts from B to C. Then if we want to add them, we will express them in the third side of the triangle in this direction. So we can put here the vector M plus the vector N. So it is a triangular vector. Here the vector M plus the vector N equals the vector M plus N, and we can express them as the vector AB, because it starts from A to the terminal point B, the vector AB here plus the vector BC equals what? Vector equals, of course, the vector AC. The vector AC means displacement here. If we have a displacement and this displacement, so or we can say distance to reach this point, we have a displacement opposite to them and reach this point in a straight way or in a short way. This is AC. So we have here some different figures. If we have a line segment here, and we have vector AB in this direction from A to B, and we have another vector in this direction BC. If you want to add them, then AB plus BC equals what? Of course, equals the vector AC. Okay, the vector AB plus the vector BC equals the vector AC. But if we have a vector start from A to B like that, and another vector starts from C to B like that, then if we want to find their sum, then we say that the vector AB plus the vector CB equals what? We can say that the vector AB plus BC, but here we have vector CB, starting point C and the end point B. So we can express it at this expression, AB plus negative BC. Negative BC here means that's the negative direction or opposite direction, but the same magnitude from B to C. Okay, let's move, my dear students, to another figure. If we have a pentagon, hexagon, or any polygon like that, if we have a polygon like that, and say we start from A, B, C, D, E, and we have some vectors start from A to B and B to C and from C to D and from D to E. These vectors, if we would like to add them, we write the vector AB plus the vector BC plus the vector CD plus the vector DE equals what? Equals the vector AE. believe or don't believe, because if we have moved from this part to this part to this part to this to reach the point A, then it's shortly as a vector starting from A to E to reach the same point. It doesn't matter in vectors. We start and we move all these vectors to reach E, but we can add them as the vector AE. Vectors here are intelligent way to add. Okay? So if we have a figure like that and we want to prove it depending on triangular vectors, we can complete the triangle here like that. So we have a vector AB and vector AC, BC, and you know from the vector, triangular vector, that we can express them by the vector AC. So we can write AB plus BC equals the vector AC. Okay. So we can substitute by AC on the two vectors AB and BC. Okay, so we can put AC instead of AB and BC. So the adding will be AC plus CD plus DE. And we can also complete another triangle like that. Okay, AD here equals AC plus CD. AD equals AC plus CD from the triangular vector. So we can express AC plus CD, this part also, by what? By the vector AD. So we have the vector AD and the vector DE. If we look at this triangle, then we can add AD plus DE, AD plus DE equals the vector AE. And by this way, we have proved that if we have a hexagon or pentagon or any polygon expresses on it some vectors in direction, same direction or circular direction as this, AB plus BC plus CD plus DA, we can express it in adding AB plus BC plus CD plus DE in the opposite direction vector, which is AE. Okay, my dear students, we have many discussions to get in vectors. Until we meet next Friday, inshallah, be happy, goodbye and good luck.